Hey everyone, how's it going? My name is Luke Wisner, and today I'm going to be walking you through a proof by induction problem. So the problem that we're given is that we need to prove by induction that 9 to the n minus 1 is divisible by 8 for all values of n greater than 0. So the first step of this induction problem that we need to do is we need to prove the base case, because by proving the base case, we're saying that at least for one term, this equation holds true. So for our base case, what we're going to do is we're going to just plug in 1 as our value. So we're going to plug in 1 for n, and what that gives us is that 9 to the 1 minus 1, which is just equal to 9 minus 1, and then that whole 9 minus 1 is equal to 8, which is obviously divisible by 8. So we know that the base case is true, which is the first step in our proof. So now we need to make an inductive hypothesis, and the inductive hypothesis is what we're going to use for our inductive step later. So in the inductive hypothesis, what we need to do is kind of restate the problem that we're given in different terms. So if we restate the problem, we get that 9 to the n minus 1 is equal to 8 times some value of x, where x is an integer, is a positive integer. So what this means is that essentially we're rewriting is divisible by 8 as 8 times x. So that means 9 to the n minus 1 is equal to 8 times some integer value that would equal that 9 to the n minus 1. So that just proves that our term is divisible by 8. Now, with those out of the way, we can move on to our inductive step. So in the inductive step, we're going to be using weak induction. So that means we need to prove that if we assume that it's equal 9 to the k minus 1, we now need to prove that it's equal to 9 to the k plus 1 minus 1. So by proving that it's n is equal to k plus 1, that is our weak inductive step. So what we're going to do is we're going to write what I said with 9 to the k plus 1 minus 1 is our new term. And so now we need to prove that this is divisible by 8. And we need to do this using our inductive hypothesis that we wrote previously. So by going back in, what we're going to do to simplify this is 9 to the k plus 1 is the same as 9 to the 1 times 9 to the k. So we're going to rewrite that just to split the 9s. Then we're going to put our inductive hypothesis back in. But to start, we're going to need to rewrite the inductive hypothesis a little bit just to make it fit, because right now it doesn't work in the form that we currently have it. So we're going to plug k in just to keep the variables the same. So we have 9 to the k minus 1 is equal to 8x. Same as up here, except we're using k instead of n. But we're going to rewrite it as 9 to the k is equal to 8x plus 1. So we're just going to take this one and we're going to put it over to the other side. And so what that means is now we can plug this term in for 9 to the k. So when we take this, plug in 8x plus 1 for 9 to the k, we get 9 times 8x plus 1 minus 1 again. So now what we can do with this is we can take we can split the terms, right? So we distribute this 9 times across. So now we have 9 times 8x plus 9 minus 1, right? So what we're going to do is we're going to rewrite this, because it's 9 times 8x, we're going to rewrite that as the same as 8 times 9x, because it's the same thing. It's still 72x. But for our intents, we need to keep the 8 out so we can prove that it's divisible by 8. And now when we take this 9 minus 1, we're given 8. So now, if you can see what we're going to do, we're going to pull out the 8 that's distributed across both. So now we have the term 8 times 9x plus 1, which is obviously divisible by 8 again, because it's 8 times the whole thing. So then, that is weak induction, given that it's true for n equals 1, and if it's true for n equals k, then it also has to be true for n equals k plus 1, and that is what we proved, so QED, we did.